Hello, am I audible?
Yes, sir.
Okay, thank you. Yeah, the previous class we understood how the expression is evaluated, okay, and about the input function and the different types, data types, and how do you know the type of any variable in Python. So just by using the type function, you can know what is the type of the variable. So just pass the variable name as an argument to type and press enter. It will tell you what type of uh, variable it is, or what is the data type of it. Okay. uh, then what else we understood last class? Okay, how to write commands in Python we understood, and the operators we understood. Okay, and the usage of the operators also we understood. So different usages, this is one thing, and this is only for the quotient, remainder, and both integral as well as the fractional part. No, I think we have to continue from this was also done. It follows the same operator precedence what you people already know, because that is a standard one and everyone should follow that. And uh, you understood more on the type, okay, and different execution sequence on that also. Okay, how the plus operator behaves on the numerical values and how it behaves on the string. And then we also understood how it behaves when it is used on one string operand and another one integer numerical operand. Okay. Yeah, and then different types of numerical values also we understood. So when I say integer, these are all the integers. Okay. So you can obtain the type of all these numbers just by saying type of this variable based on the assignment what you are doing. And type conversion, this is what we were discussing. Okay, when we put an integer and floating point in an expression, the integer is implicitly converted to float. So in this we have this way I'm casting it to float, and this is integer. And when the mathematical operation addition is performed, we have it converted into float, implicitly the result is implicitly converted into float. And in this example, I is equal to 42. So type of I am trying to print, it says it's a class, it is of class int. Okay, so it says class int because int is a class again. Later you'll understand when we go to the concepts of objects and classes, there you'll understand. So int is a class, str is a class, float is a class. These are all the classes. Okay, so later you'll understand. And then again, what I'm doing now, casting this same I value to float, and I'm printing it. And when I check the type of f again, it says it is of class float. Now, so this is telling you the integer division, various forms of integer divisions. So when I say, as you already understood this operator, the division operator, when you perform on the integers, okay, it will give you both the integral as well as the fractional part. So you can observe here one more example. So you can observe this as well again here, 99 divided by 100. So you're getting both integral as well as the fractional part. So and the same is true when even when you're doing the floating point division, 10.0, both are floats. So this is. But this is the result what you get in case of Python 3.x onwards. At that, to be more specific, 2.7 onwards. It's something like this. This is the behavior. But if you execute the same statements using the Python version, okay, 2x, or the Python version which is below, which is 2.7 below. So you'll get a totally different behavior. So now we don't use it. Now Python 2.7 is depreciated, we never use it. So Python, so 3.6 what I'm using, so it's preferred to use the Python versions above 3. Okay. So now string conversions. I hope the screen is visible. Do I need to make it full screen, or is this okay? Hello? Loda, I'm not able to hear.
It's visible, sir.
Visible, okay, no? If I go like this, yeah. So you can also use int or float to convert between string and integers. So if you get an error, you will get an error if the string does not contain the numeric characters. So something like this. These are all the examples. Similar type of examples even I have executed last class and I have shown you. Say for example, this is a string and I'm just trying to convert it into. Just observe my mouse movement. Or let me go to full screen. Now here, the string. Let me start from here. So this is a string which I have assigned because it is written. Anything which you write in single quote or double quote is a string in Python. And now type s value. It told me it is of type class string. And then I'm trying to add to the string the numerical value 1. This is no longer an integer now. Numerical value. It is not a string. Now the mismatch is there. Now whenever you are using plus operator, either both should be numerical operands or both should be string. Now this is string and this is numerical, and it says cannot convert the int object to string implicitly. So this is an integer object, and it is saying I cannot implicitly convert this into str. In case if you are doing this as str, then it will perform the concatenation operation. So next, I'm trying to convert. So this is 1, 2, 3, which is a numerical value. So which was earlier typed as string. Now I'm casting it into integer. So ival, integer value, and type of ival. Now it says it is of type class int. Now to this you can add 1, and even here also. See, this is a string, what you are seeing. So we are trying to cast this string into an integer, which is not possible. Okay. Now we have this message conveyed by the Python. Value error, invalid literal for int with base 10 x. Okay. So this is not possible. You cannot convert this into integer. Now user input, this you already know. Okay. You can read and you can also go for printing the same. So even in Python, for the function print, you have something called as print list. And yesterday I also showed you how to reserve the place for displaying the values which are there in the print list. And this is the program, okay, which was already explained. And now this has a majority of the things what I told you now. The only few things you don't know yet. Say this is input, you know already, and this is the function for opening the file, and this is for creating the dictionary. So when we'll be discussing this in the second module, you'll understand this. So dictionary is less. These are all the important data structures which are available in Python, and which you can most widely use to handle the data. So this is the programming language which is best suited for the data science applications. So summary. So till now you understood the type function, you understood reserved words, you understood variables, how to create variables in Python, you understood about the operators, you understood about the precedences, operator precedences. Now how to do the division operation, most importantly the integer division, and how to get say in case if you're interested in getting the result both integral as well as fractional, how to do it. Now I just am interested only in the integral part. Okay, what is that I have to do? I'm interested in only the remainder. What is that I have to do? All these things. And how to convert from one type to the another type. Okay, that you understood. User input, you understood how to get the input from the keyboard, and how to write the commands in Python. So this is what the summary of the entire thing what we understood till now. Next, so after discussing all the basic elements of the Python programming language, okay, so we are into discussing the advantages and disadvantages of the Python programming language now. So this Python, no doubt, it is an high-level language. So similar to other high-level languages like C, C++, Perl, and Java. So Python is also an high-level programming language. And there are other low-level languages also. Sometimes you call them as machine language or assembly language. So, and computers, they can easily execute this programs written in low-level languages. So even in the previous semester, you have understood the microcontroller, and you know how to write the embedded C programs and the assembly level programs, ARM programs they are written. So the ARM programs what you wrote earlier, they are all assembly level programs, and for the Part B programs you wrote the embedded C program. So the programs written in high-level languages have to be processed before they can run. Okay, so even if you are writing the program using C, C++, Perl, or Java, or Python, so they got to be converted into the lower-level language. Okay, so this extra processing takes some time, and which is a small disadvantage of high-level language. So this is what the disadvantage. So because the moment you write the high-level language, it cannot be executed as it is. You got to convert it from the high-level language to the machine language. And for this, sometimes you use the translator, and sometimes you use the compilers, and you get the machine code, or and then that is what will execute. So that is the only. But if you are writing directly the program using the machine language or the assembly language, this translation time is not required, and you can avoid. Now advantages are enormous. Okay, so this is the disadvantage what we mentioned. Okay, of the high-level language, but advantages are plenty if you take the high-level programming languages. So first thing is, it is much easier to program in high-level language. So programs written in high-level language, they take less time to write, and they are shorter and easier to read, and they are more likely to be correct. Okay. So you can just compare the program written in high-level language and the program written in low-level language. So low-level language, it will be a little bit lengthier. So high-level language, it is always short and easy to understand. Okay, more likely, and all these things you know. And the second important advantage is high-level languages are portable, meaning that so they can be run on different kinds of computers with few or no modifications. Sometimes you may require few modifications, and sometimes you don't require any modification, and you can easily run on different computers with hardware and software configurations. So low-level programs, so they have the limitations. So they run only on one kind of computer, so that they have to be and they have to be rewritten to run on the another computer. Say for example, if I am programming on some kind of a processor, writing an assembly code, so it runs only on that. So if I want to make it run on a different computer, so I got to do the entire rework. The program, the entirely new program has to be written. Okay. So this is the advantage of high-level language, and disadvantage of the low-level language. So then two kinds of programs. So the process high-level languages into low-level languages. So what are those two programs that processes and converts the high-level language into low-level language? You already know. It is the interpreter and compilers. Now what an interpreter does, interpreter reads high-level program and executes it, meaning that it takes a line of the high-level statements and it performs the execution. So it takes a line and performs the computation. You have the source code. Interpreter, what it does, it takes one line at a time from the source code and converts it into processes it and produces the output. So where the compiler, what it does, it takes the entire source code, compiles it, checks for the syntax error. If there are no syntax error, produces an object code, and we have an executor which performs the execution of this object code, and this object code can be taken from one system to the another system and it can be executed. Now, so you understood, okay, high level language and low level language, advantages of high level language, low level advantages of low level language, and at the same time what are the disadvantages of high level and what are the disadvantages of low level, and how do you process an high level language into low level language. Either you should be using the compiler or the interpreter. Now, Python is considered an interpreted language because Python programs are executed by the interpreter. Even in my earlier classes, I told the Python is written using the C programming language, and it is an interpreted language. Okay. Now you write the program and you can interpret using the Python interpreter. Okay. There are two ways to use the interpreter. One in the command line mode, another in the script mode. So this even I have already told you. So command line mode is nothing but the interactive Python shell. You can directly go there and you can issue the Python commands, it executes and gives you the response. If there are too many commands to execute, then you'll go for executing it using the script mode. And that is what I have written. In command line mode, you type the Python programs and the interpreter prints the result on the fly. So now, okay, now with this understanding, now I want you to write a Python program which prompts the user for hours and rate per hour to compute the gross pay. So write a small Python program which prompts a message asking the user to enter the number of hours what he has worked, and after that it should immediately prompt what is the rate per hour. So you enter the rate per hour and it should compute and give you the gross pay, the total amount of pay to be made to him. So just start writing. Start writing and put the answer in the chat box. I'll check. So write your answers here. Again, my status is saying you are in DND mode. While sending, you can make the messages as highest priority message. I think I'll receive it. Yeah, are you people writing? Anybody have responded? Able to hear me? Am I audible? Students? Yeah,
Yes,
okay,
sir.
okay. No response yet, please.
5C, sir.
Oh, sorry, 5C. No, got confused. Yeah. Okay. CS 103, are you there? CS 130. One zero three 132. No, have you posted in the chat box? Okay, I got 18C025. Okay, I'm getting now. Okay. I think from here and you can make the message as important and send it to me. I don't know. So one response is float input, enter the number of hours and input rate and multiplying. Good. Okay. Print the weight. Okay. Okay. So even others can also send and write. Okay. Write and send. Sorry. So now I'll just move back to my PPT. Okay. Yeah, this is what we did now. So input arts, that you should be very careful while naming the variables. That is what I told earlier also. So be careful while naming. You have to give a readable name, and that name should be again short. So for ours, I've taken it as HRS. So best practices you have to follow. Rate, all these things. Okay, and then casting them to R, float. So and then multiplying. So and then just printing it as a gross pay is equal to so and so. Okay, do this now. One more program. Write a program which prompts the user for SLCS temperature, convert the temperature to Fahrenheit, and print out the converted temperature. So same as the previous one. Only thing is you should know how to convert the Celsius temperature into Fahrenheit. That's all. So do it. And put the answers here. Okay. Now let me give my response. Okay, written in one line. So that is the beauty of Python programming language. See, everything is written in one line. See, so that is the beauty of Python programming language. Print wage is equal to read hours, convert it to float, multiply, input rate, so everything. Nice. Good. and this hours is equal to this, enter number of hours, casted there. Good. Yeah, even I got the answer for temperature. Okay. So input Celsius, Fahrenheit is equal to, okay, Celsius into 1. Even I am not sure with the formula, but solution I have. So but I'll give thumbs up. Good. Okay. Okay, that means you people are active. Okay. Okay, good. I'll go back. Let us see now the formula. I think it's correct. So I'm just saying Celsius to Fahrenheit conversion, reading the Celsius. This is what the formula is. Okay. After the Celsius is read, so float I'm converting, and then this is the formula, and then we are printing it. Okay, and this I think I need not execute it because I've already told you this. Let me skip. Next function calls. Okay. So there are many built-in functions which are available in Python, and few of them you have already learnt. Input is also a function. Okay, and then type, what we saw in the previous class and today, is again a function. And so there are examples also. Okay, instead of printing the return value, we could assign it to a variable. Say this is what I'm doing. See, type also returns. See, this is I'm just executing without any LHS. Type 32, it told me string. So now what I'm doing, so I don't want the type value to be printed. I just wanted it to assign it to some other variable. So I have taken Betty is equal to type 32. So now the type of 32, which is written in double quote, is assigned to Betty, and then I'm printing it. It says me type str. Okay, this. Now there is another function with the name id. Okay, so this will you pass anything to this function, it will return you an unique id. Okay, so I'm saying id, I'm passing 3, so it is giving me this id. Now what this means is, so this is the address where this particular value is stored. Okay, and I'm doing one more, Betty is equal to 3, id of Betty I'm saying. So again it says this is the address where this particular value is stored. So like this. So if you're interested in knowing the address where a particular value or a variable is stored in the memory location, so you just pass it as an argument to id, you'll get it. Okay, so every value has an id, which is a unique number related to where it is stored in the memory of the computer. Okay, so where it is stored in the memory of the computer is nothing but what? The address. Now type conversion functions. Okay, this what we have already understood. Okay, provides a collection of built-in function that converts a value from one type to another. Int is one such function which converts the given value into an integer. Okay, and here we have one more example, 3.99 converting it into integer, and int minus 2.3 converted into integer minus 2. Now similarly float, you know this, and converting this string, which is numerical value, to float. So str, so I want to convert this, 32 is a integer value, so I'm converting it into this. Okay, now this note is important. So Python distinguishes the integer value 1 from the floating point value 1.0. So they may represent the same number, but they belong to different types. So when you give integer 1, it says it's an integer. So when you give 1.0, so it is a floating point value. The reason is that they are represented differently inside the computer. So next we have type coercion also. Okay, to understand type coercion, so this is what the example I'm taking. Say I want to suppose I want to calculate the fraction of an hour that has elapsed. What is that I'll be doing? Number of minutes divided by 60 seconds I'll be doing. Say for example, so now it is 30 minutes. Okay, I want to tell that in terms of hours. What is that I'll do? So 30 divided by 60, something like this I'll do. It says it tells me what 0.5 hours, something like this. Okay. Now when I'm doing this, I've taken this example here. Okay. So now when I'm doing this minute divided by 60, what it returns me is integer arithmetic. It always returns me 0. Okay. So even if the minutes is 59 minutes, so and past the hour, what it will do? It will return me 0. Now in case if I am doing this, say minute is equal to 59 and float of minute, I am casting this 59 into float and divided by 60, I get this. So this is 0.9 hours, something like that. Okay, 0.98 hours. Next. Now what I am doing here, I am explicitly converting minutes into float and then dividing by 60. I am getting this hours. Now alternatively, you can also use the automatic type conversion. Okay, so this is called as type coercion. Say for example, minute is equal to 59. Now I don't want to cast this to float. So what I can do is this denominator what you have, you write it as float. So earlier we wrote it as 60. Now I'm writing it as 60.0. Now you get it. This is what is called as type coercion. Okay, by making the denominator a float, we force the Python to do the floating point division. Okay, so earlier if I'm not giving this, now here, now I was explicitly making minute as the float, and then we were dividing. Now what I'm doing, I am not doing anything to the float, but the denominator I have made it as float, and this will force the entire value to be in the floating point division, result to be in the floating point. So next, math function. So in mathematics we more frequently use sine, log, all these things. Okay, and we have learned already to evaluate sine of pi by value, all these things you know. So first we evaluate the expression in the parenthesis again. So this pi by 2 we do, and then sine of an angle will find it. Okay, like that. Now when log also you can find similarly, correct? No? So log of a value I want to find. So sine of 1.571 is 1 and log of 0.1 is -1. So all these operations you can do. So in Python, if you want to do any of the mathematical operations, or if you want to use any of the mathematical functions like sine, log, or it may be any other power or cos, something like this, so then you got to import a module called as math module. So by default you will not find the math modules. So if you want to use the math modules in your computation, so then you have to import this module. Math module provides most of the similar mathematical functions. So you got to import this. Okay, how to import I'll show you later. Okay, it's written here, import math. This is what you have to say. If you just say import math, so you have the math library, entire math library imported, and it will allow you to use all the mathematical functions which are available here. Okay. Next, what is a module here in Python? So module in Python is a file, and what it contains all the related functions group put together. So and even it is easy for you to make a module. Say for example, you are writing few functions, related functions, group all of them, make it as a file, and the same file can be, you can make it imported by the other users or in other programs. So you can do that, and later you'll understand how to do that. So module is basically a file which contains a collection of related functions which are grouped together. Now how to import it? So you got to use the keyword import, and the name of the module you got to write, and the name of the module here is math. To call one of the function, say I need to call one of the function which is there here in the math module. So we have to specify the name of the module and the name of the function separated by a dot, okay, or you can call it as a dot, and sometimes we also call it as a period. So this format is called as dot notation. So we use the dot notation basically to call any of the function which is available inside the module which you are importing. And this is similar. So even structures you have understood in C programming language, there you do the same. Then if you want to access any of the structure member, so what is that you do? You write the structure variable dot operator and the name of the member. That is how you access it. And similarly here in Python, if you want to access any of the function which is present in the module which you are importing, you have to use the module name. That is, here the module name is math dot the function name which is there. So for example, in math I'll find the sine function. I want to use the sine function. I just say math dot sine. It goes like that. Now here I have the example now. Say math dot, I want to call log10 function which is available in math module. First I import math module and then I say math dot log10. So I'm 17.0, I'm converting it into decibels. Okay. So sine of an angle I want to say, I want to find the sine of 1.5 angle. So math dot sine an angle I'm passing. Okay. So like this. Yeah, and this is important. See here, the sine and other trigonometric functions which are found inside the math module. So they take arguments in radians. Okay, to convert from degree to radians divided by 360. Say always whenever you pass something as argument to trigonometric functions which are found inside the math module, so they take the argument in the radians. In case if you want to pass it in terms of the degrees, you got to divide it by 360 and multiply by 2 into pi. So I think you know this already. So this is what we are doing now. See, so this is the degree 45. So I'm just converting it into angle, degrees into 2 math divided by 360, and now I'm passing this angle as argument to sine. So sine of 45, so I'm getting this. Next is composition. So Python functions can be composed, meaning that so you can use one expression as a part of another. Okay. So example, so it can be a compound expression, something like this. Okay. And if you look into this, you'll understand. See math dot, so there is an one more function with the name exp, and to this exp I'm again calling math dot log of 10. Okay, like this. That is, this is what is composition. So it's not like it should be one simple argument. Even the argument which you pass to this mathematical functions which are there inside the math module, so they can be even the compositions also. That is one expression as a part of another. Okay. Now, so till now you understood the built-in functions of Python. So there are few functions which you can use even without importing anything. Say for example, the input function you don't have to import anything, and the type function you don't have to import anything, int, float, all these things you can use without importing anything. So especially when you want to use the mathematical functions, you have to import additional packages, additional modules. So math module we imported and we used some functions from there also. Next, adding a new function. So till now we understood the built-in functions. Now how do I write my own function? Okay. So far we have been only using the functions that comes with the Python, but it is possible to add a new function also. You can define your own function. Okay. What is a function? You can group the related statements there. Okay. Or in programming context, a function is a named sequence of related statements which you write, and if you want those statements to be repeatedly called, so instead of repeating those statements, you can just give a call to this function and you have those statements executed. Now the syntax of defining your own function, it goes like this. So it starts with the keyword def. Okay, so this is the keyword, and this is the name what you are giving to the function. So there's the name of the function and the list of parameters, and you should have a colon, and followed by this you have the statements, and you should have an indentation here. So just if I want the statements to come under this function, I got to do with the indentation. So this is how this is syntax of creating the function. Okay. So first you got to make use of the keyword def, name of the function, list of parameters, and it is a colon you have to give, and then the list of statements with the proper indentation. And name, we told function name. So you can give any name that you want for the function except the Python keywords. So I told there are 33 reserved words in the Python. You cannot use them except those things. You can give any name, and again when you're giving, you got to follow the identifier naming rules. Okay, that is what you have to follow. And list of parameters specified what information, if any, you have to provide in order to use the new function. So if you have any parameters to pass in order to for the new functions to execute and perform the computation, you can pass the parameters here. And the statements what I told, they got to be intended properly from the left margin. Okay. Now I have this simple example now. Can anyone tell what this, if I call the name of the function is new line, so I can call this function by just writing new line, and what this will do? Now print function you have already understood earlier also. Now within this function new line, I have only one statement written, and that is print without any argument. So till now you saw print function with an argument, correct? But for the first time we are writing the print function without any argument. What will happen?
It skips a line.
Yeah, it skips a line, and or you can say new line, correct? No, it skips one line and goes to the next line. Okay, that is what. So hence the function is named as a new line. Okay, next. Now I need to call it. I need to call this function new line. So I have given the definition here. Okay, the new line. I need to call. How to call? Like this. Syntax of calling the new line function is same as the syntax of built-in function. So you have called the built-in function type. You have called the built-in function int, float, print, everything. Similarly, you can call. Okay, so print first line. So there is no opening and closing parenthesis, and this statement works well for the Python version 7.2.7 and below. So but 2.7 onwards, you got to use the bracket. Okay, I hope you people can understand. So print first line, and then I'm calling new line, print second line. See, this line is skipped. There is a blank line given here. Okay, so this is the output. This is the output of this program execution. Now can I do this here in the interactive Python cell? Yes, it can be done. I'll just show you this. I'll go to the previous slide. Yeah, I'll copy this. So copy. So I can do it here, interactive Python. Okay. Here also you can do. Otherwise, I can write it in the form of a program also, and I can do it. So I've defined a function with the name new line, and there is only one statement written inside it, that is print. Next, I copy my other program. These statements I'll copy. Okay, let me change this. So this character I need to change. Okay. I press enter key. Since the function is already defined, new line, it calls. See, first line, and there's a blank line here, and then the second line. This line is skipped. Okay, next. Now if I write without this, let me delete this. Okay, now what will happen? So you don't have that blank line. Okay, so even the function also I defined in the interactive, so that is also possible in interactive Python cell. Okay, you can, even the function, any function definition you can write directly in the interactive Python shell, and you can write the set of statements and you can call that. Okay, and same thing if I want to do here in the form of a program. Let me go to the new. So I'll just copy this same thing, put it here, and I'll copy this. So I don't want this to just intend under this function. I'll just go to the beginning. I'll put it. Let's save this. Okay. I'll save it as s.py. It is saved now. Now let me clear this CLS. Now I'll run this. Same thing. So now this s.py got executed, first line blank and second line. Now I got executed it as a program. Okay. Earlier I executed it in the interactive Python shell as a command, one after the other. Okay. Next. So what if we wanted more space between the lines? So then I have called the same function 3 times. Okay, the same function repeatedly called 3 times. Okay. Now what I've done, so it was a new line function. Now I'm defining one more function with the name 3 lines, and in that 3 lines I'm calling new line 3 times. So it can be nested. Okay, we are nesting new line in 3 lines. Okay, so this nesting is also possible, and this nesting of function call can go to any depth. Okay, so no limitation. Say I can have this 3 lines called in another function, say 4 lines. I can have that 4 line function called in 5 line functions. Okay, this nesting can go to any depth. Okay, so let us quickly do this in the interactive Python cell. So there is already the function new line, okay, defined. Now what I'll do is I'll define this function. So definition 3 lines, and in that I'm calling this. So 3 lines is done. So now I'll write this. Three lines I'm calling, so it calls this, and this in turn calls new line 3 times. Since I've already defined new line, it is there. The definition of the function new line, it's already there. See, you have 3 blank lines. Okay. So until I close this interactive Python console, all the variables or the functions, whatever you define, it will be there. The moment I close this console window, it will be removed. It'll not find it. Even if I do clear screen, it will be there. Even if I'll do CLS, now the definition of new line is also there, definition of 3 line is also there, still there, it is there. Okay, go to the next one. Okay, this is the last slide here. Okay, 70. Okay, next is iterations. Loop and iterations. Okay. So this repetition, few repetition statements, for loop I showed you in one of the program, that is word count program, word count frequency program. Okay. Now here again, so this is how the syntax of the while loop is. So I have the variable n initialized here, and while you got to write full, while n greater than 0, and you got to have the colon. Okay. So print n and n is equal to, now how many statements are there under this while statement? There are two statements. One is print n and n is equal to n minus 1, and these two are outside the while loop. So the one disadvantage of this Python programming language is that indentation. So if it is a very small program, you can easily understand, but if it is a big program, so this indentation is always a problem. Okay. It confuses sometime. So which statement is under which looping construct, or which statement is under which function. So especially when the program length is very big, so this problem will arise. Okay. Yeah, and I don't have to explain the logic of this program, how it works. This is the kind of output what it produces. Okay. So I am printing from 5 to 1. So and then it says blast off and then 0. So an infinite loop, something like this. Now n is equal to 5, n greater than 0, and nowhere inside the while loop I am decrementing the value of n. So it says what? Infinitely it will do this. Okay. So it runs into an infinite loop. So a washing machine program it is. Okay. Now another loop, n is equal to 0 while n greater than 0. Okay. So this never executes. The statements here under the while are never executed. Okay. Now breaking out of a loop, so that is also possible. You have used a break and continue statement in other programming languages also. Similarly, break and continue is also allowed here. Okay. Now I have while true. So whenever I write while true, it is an infinite loop. Input, I am reading something, okay, from the keyboard, and I am just checking what I have read. So if I have read it as done, I just come out of this loop. Okay, break the execution of this loop. So if I type something else other than done, it keeps looping here itself. As long as I type done, so I infinitely it will go for accepting something. And what is that I am prompting on the screen? This greater than symbol. Every time I type other than none, I have this greater than symbol prompted, and it will wait for you to enter something from the keyboard. So initially I typed hello there. Are you people there? Yes, you are there and listening to me. And then finished. Okay, I typed again, it told me finished, you typed. Now I said done, it told me done, and it is out of the loop. So the loop got terminated. Okay, so I got this done printed. So done printed because it came out of the loop. Okay, we will end here for today, and we'll continue in the next class, tomorrow's class. If you have anything to discuss with me, please do discuss. Hello? Even all these things can be executed in the interactive Python shell, so we'll do that in the next class. Are you people there? Yes, mute. Please mute. No, I don't know. What time it got disconnected? I was disconnected.
124, sir. 124, 125.
Okay, okay. I just came to know now. Okay. Now, what was the last topic I was doing when it got disconnected? Hello? Oh, again I'm leaving. I'm joining it.
ಯಶು ಮತ್ತೆ ಹೋಗ್ಬಿಟ್ರು ಸರ್ ಅವ್ರು ಬಂದ್ರು ಅನ್ಸುತ್ತೆ.
Yeah, I don't know. It got disconnected.
ಯಶುದು
Hello? Hello?
Yes, sir.
Yeah, what was the last slide I was discussing before disconnecting?
Use the refined functions.
Oh, that was okay.
Nesting functions.
Nesting functions, okay.
Two functions.
Okay, okay. I didn't notice that I have disconnected. It's okay, no problem. And only when I changed the slide, I came to know that I was disconnected. So, okay, I think 5 to 6 minutes I was disconnected. From tomorrow, I'll continue from there, from the nested function. Okay. So,
Okay, sir.
yeah, now we will end. So, I've left my phone there only in my chamber. So, next class when I come, I'll come with my phone. In case if I get disconnected, please just one of you can call me and inform. Okay.
Okay.
From the next class onwards. Okay. Thank you now, and you can leave.
Thank you, sir.
Yeah.